Hi everyone, welcome back to my channel Skillset Academy. So we are in day 6 of our Cisco SD-WAN from scratch to advanced course, right? So earlier we have done 5 more videos, right? So if you haven't watched this video, please go to this description videos and watch all those videos. Then come to this video and you will be able to understand more, right? So we are focusing today we are focusing on the very special protocol for this SD-WAN is overlay management protocol, right? So this is the fundamentals we have to understand before going to lab, right? So let's break it down, right? Using a earlier protocol like BGP, right? So please stick around till the end and don't forget to like, comment, and subscribe for more videos, right? So let's jump into the OMP. So overlay management protocol basically it's a TCP based protocol, right? It's a TCP based extensible protocol. So what do you mean by extensible, right? So extensible means if any kinds of improvement needed in further, because we know the SD-WAN technology is evolving technologies, right? It's evolving now. So in future, if need any changes on this protocol, it can be possible, right? Because it's extensible protocol. And like I told, this protocol is a similar to BGP, almost similar to BGP, right? So as the BGP is also a TCP based protocol and it uses port 17900 and you know the BGP port number is 179, right? It added two zeros, right? So as it's a TCP based protocol, so it will establish the TCP three-way handshake, right? And its uses to maintain the SD-WAN control plane, right? So we will discuss more. Okay. So this SD-WAN run between the controllers means earlier name was vSmart, right? So it run between the controllers and between the controllers it forms full mesh. Okay, so you can see the all controllers have connectivity each other, right? And it runs between edge routers and controllers. Okay, so you can see this is the edge router and not need to form full mesh with these controllers. You can see we have 3 controllers here, but we have 2 connections with this controllers, right? And the connections will be active, right? And one more thing here, the OMP configured to handle overlay routes and transport locators. The TLOC acts as a next hop for overlay routes similar to BGP, right? So what this mean? So in BGP, suppose you have a router here and you have a router here, and in between you want to run BGP, right? You want to run BGP. So and let's say you have a subnet here, let's x.x.x, and one more subnet here is the let's say y.y.y, right? So y.y.y, and you want to share these subnets to this router, right? So when you advertise this subnet to this BGP, so when this receive this router, so what it can see is see if I want to, if this X want to communicate with Y, so the next hop would be this IP, right? 1.1.1.2, let's say, and 1.1.1 here, right? So this IP would be next hop to reach this subnet, Y subnet, right? So likewise in SD-WAN, if you send this subnet have to uh, go to down here. So this is the diagram which I have found in internet. So I attach it here. So this is the edge router, right? And this one is edge router. And here we have a campus network with the connected route and static, right? So the control connections OMP is running on this controller and this CH or VH router, and the OMP will not run between these edge routers, right? Because this is the data plane, and this OMP is a control plane protocol, right? So this data plane, between this data plane, the IPsec or data plane protocol IPsec will be run, right? So let's say this is the router, and in routers we have a subnet, right? Again, let's say this is the x.x.x subnet, and here this is y.y.y subnet, right? And this network, if you want to send this network to this network, right? Want to communicate both networks, right? So what you will do, you will just redistribute this connected or OSPF network to this OMP, and this OMP will again distribute to this route to another edge routers, right? So when this device edge distribute Y network to this edge router, what it will say, what is the next hop? The next hop would be this TLOP, right? So this is the transport, and we already covered what is the TLOP, right? What is the system IPs, right? So what is the control plane, data plane, right? What underlay, overlay. So I requesting you to, if you haven't watched my earlier videos, please go to watch and come back to this. So you will have more clarity what is going on, right? So this edge router will see this edge router to reach my network, my subnet. Your next hop would be my TLOC. Suppose TLOC 1, and here this TLOC is TLOC 2. Okay, so again, if these routers send this subnet, it will use this TLOC as a next hop. So this router will see T2 as a next hop IP. So what is TLOC? TLOC nothing but a combination of system IP, color, and encapsulation IPsec or GRE, right? So this here in OMP, that next hop is TLOC, right? So there are three types of routes advertised in OMP, right? So one route is OMP route, which is called also V route, which is similar to BGP's prefix, right? In network prefix. Likewise, OMP route is a V route, which is similar to BGP prefix. Another route is TLOC route, which is represent the end point of data plane channel, right? So let's say we have two routers, right? This is the one router, and this is the routers, right? Let's come to this picture again. So here, so this is the LAN network. This is the LAN network or LAN prefix. It calls V route or OMP route, right? OMP route or V route. Okay. In similar way, this BGP we call this prefix, right? And we advertise this prefix to BGP using network command or null command, right? Again, T-lock routes. T-lock routes, nothing. It's a T-lock. What I earlier told you, the combinations of system IP and the color and the MPLS. Including this, there are multiple attributes which travel with this T-lock routes, right? And another is a service route. Service means you have firewall routes, you have a firewall or IPS or load balancers, right? IDS, whatever the service is called a service routes, right? So all service routes as well as T-lock routes and OMP routes, right? So when these edge routers forward these routes to this controller, and these controllers will send to this other edge router. Likewise, the BGP route reflector, right? It's using route reflector as BGP. Okay. And whenever the devices have both informations of your neighbor informations, it will form the data tunnel or IPsec tunnel, right? So again, the responsibilities of this protocol. So we already talked the distribution of transport locations among network sites in SD-WAN domain. So you have a 10 sites, and uh, between 10 sites you share the all informations via or using this OMP protocol, right? And distribution sites, service side reachability information. So we have already discussed the sites networks, right? The service sites in SD-WAN, we have a three types of VPNs, right? Transport VPN, management VPN, and service side VPN. You can find the all information to my earlier videos, right? So this is the service side VPN. So all service side reachability information, it will send to this sites. If you have 100 sites, it will send all 100 sites, right? And service chaining information. So if you have uh, your firewall in your fabric, right? Or if you have load balancers or IPS, IDS, all informations will be shared between these sites routers via controllers or vSmarts using OMP protocol. Okay, and encryption key also, right? So in traditional networks, if we want to build IPsec tunnel, so we configure I or phase one I protocol, right? Internet key exchange protocol, and in I we have two phase one and phase two, right? In phase one, we run ISACAM as a control protocol, right? So ISACAM will be run as a control protocol. So what it will do, it will share the pre-shared encryption keys, right? Authentication keys, development group, all cyber suites with it with its neighbors to authenticate each other, right? Same wise, so in SD-WAN, there is a slight difference between a traditional IPsec and SD-WAN IPsec. I will cover this difference between IPsec in upcoming videos, right? So likewise, in traditional networks, it also share the their parameters to configure these IPsec tunnels via this OMP update, right? And distribution of data plane security parameters, VPN labels, and crypto keys, what I discussed now, right? And also it's a application our routing informations, right? So it's uh, add some features, right? We will discuss when we are when we'll be starting, we will start our lab, right? So there are some key points what OMP do in SD-WAN, right? So OMP built in between the OMP pairs established between system IPs, right? In traditional networks, we use the loop back, right? So system IP is a logical IP, right? It's not physical interface, right? So if I want to communicate, establish the BGP with a loop back interface, so what we will do, we will use loop back interface to form BGP, right? So it will use for redundancy, right? Because this logical interface will not goes down, whether the physical interface will goes down, right? So if you have multiple links, so you will use this logical link, so your uh, peering will not goes down until or unless your device not goes down, right? So again, OMP runs under the DTLS secure tunnel, so your MPLS will not run, your OMP will not run in this way, right? In this transport, it will form first. It will form the DTLS connections, DTLS tunnels, right? Under this DTLS tunnel, this OMP update will traverse, right? So this will be a tunnel. DTLS tunnels by default it forms. You can change it TLS tunnel as well, right? So it will form TLS tunnels and all informations will be encrypted, right? So it's a secure tunnel. Okay. Another point is default when edge router try to build data tunnel. So it's a separate things when we discuss data connectivity. So if you have a two or three WAN interface and WAN connectivity like internet MPLS 43G. So these edge routers by default, it will try to form IPsec tunnels, right? So it will try to form full mesh connectivity between all edge routers. If you have 100 edge routers, all edge routers will try to form connectivity to all routers with all transport, right? By default, it try to form the full mesh tunnel. To restrict this, so we have to use color restrict option in interface tunnel option in a tunnel, right? Another point is administrative distance of OMP is 250, right? For VH and Cisco SD-WAN device, it is 251 by default, right? And another point is OMP is enabled by default, does not need to be enabled. Controlling SD-WAN networks works in BGP route registers in BGP. We have discussed earlier, right? So it's by default enable and you will not disable this, right? So you no need to configure this OMP routing protocol, right? Again, one more point is OMP can support graceful restart. So what graceful restart? If uh, as we discussed earlier videos, so we have separate control plane and data plane, right? So if your control plane will goes down, so there is a time by default. This is the 24 hours. We can change it, right? According to our need. So it's a changeable, right? So if the controllers will goes down, there will be no impact on data connectivity or data plane connections. So if this control plane goes down, this goes down, there will be no connection with this edge router. Still, this router will traverse their packets. There will be no impact on data connectivity, right? Still, these graceful times are set, right? If you set 24 hours or 36 hours, until 36 hours, it will share your data connectivity between edge routers, right? So this is the graceful restarts, okay? So OMP can support the graceful restart, so it allows when edge to cache forwarding information if connectivity to the controllers is unavailable, right? And one more thing is controller advertise for equal cost routes by default, but it can be configurable, right? By default, it supports equal cost multipath in 4 WAN interface. It can be upgradable. It can be 16. Okay. So these informations will be useful if you want to crack your SDWAN or CCNP or CCI exams, right? So I've covered all the things, right? So, if you run show control connections in your edge routers, you will get this OMP peer connections details, right? So if you have multiple interface or multiple transport, you will get, if you have 3 interface, one interface, it's the internet, MPLS or 4G, 3G, right? You will get 3 pairs. Okay. So OMP control connections will be 3. So here you can see the system IP is same, right? It's the running DTLS protocol, and system IP is same, but color is different, right? So the T-lock will different, right? Due to this color. Okay. And the if you have this is the your V Smart, and this is your routers, and here is the ISP, right? And you have 2 or 3 links with ISP. Okay. So your DTLS connections will be 3, but OMP pairs will be 1. OMP pairs will be 1. Why 1? You have 3 connectivity with this edge routers, but why 3? uh, we have 3 DTLS connections tunnel, but we have OMP pair 1, because this OMP pair built on system IP, and as we know, system IP is unique in the individual devices. All devices have unique system IP, right? Like our router IP ID in traditional networking, like OSPF, OSPF and BGP or EIGRP, right? So OMP pair will be formed with the system IPs, right? And in BH router, you run show OMP peers, and CH router, you have to run show SD-WAN OMP peers, and you will get this peer informations, right? So you can see we have 2 T-lock information. We have 2 T-lock, but we have OMP single OMP peers, right? Okay, and like BGP, it shares some message, right? So I have compared it to BGP. In BGP, we have 4 messages, right? So open messages after TCP handshake establishment, the BGP first packet will send open message, right? Here it sends the handshake message, right? The handshake message is the first message sent by each sides after TCP connection is established, and it shares the all attributes, all routing attributes on with this handshake message, right? And another message is update message. So all types of routing informations will be shared in BGP with update message. Likewise, in SD-WAN OMP protocol, the OMP protocol uses the update message to share all the routing informations between these sites, right? And another is keep alive message in BGP to check the reachability between the pairs, right? It uses the keep alive message. Same wise, the OMP uses hello message to check the reachability between the pairs, right? Periodically sessions, right? And another notification message. So in BGP, if there is any issue with this peer, right? So it will send the notification message to its peers, and in SD-WAN it shares alert message, right? Alert message to this pair if anything happened to this connections, right? And extra message is query message in OMP. So this message is used to send a request to a specific route for which an aggregate or less specific route exists. This message is sent by an edge device once it finds out the group of prefix received is equal with the query attribute. So if in a site it will found the group of routes, it will send the query message to get all the routing informations, right? So hope the overall informations of OMP, right, will help you to understand the SD-WAN technology, right? So thanks for watching. I hope this video help you understand the concept of OMP, right? And please like and subscribe if you found this video helpful, right? So, and please subscribe my channel to grow more subscriber, right? So thank you for welcome to view upcoming videos.